Hey everybody, this is Michael Parent with Michael Parent Consulting Services. Today what I wanted to show you is how we can build a sophisticated simulation, a sophisticated operations model right within Excel. So this is called a Monte Carlo simulation, and it has the advantage of a lot of the other tools that we use to create more what we'll call stochastic or random processes. We can also introduce all kinds of other things like randomness and statistical probabilities and logic that better model our operations. Oftentimes when we work with industrial engineers or we're using industrial engineering tools, we build these big models, capacity models, time standards, and they're very helpful, but they have a lack of sophistication to them because they're deterministic. They use point estimates to say this is the average cycle time and this is the average product mix that I'm going to get. And when we use that, they're simple to understand, they're simple to communicate, but we lose our ability to understand the operational dynamics as our process varies and changes and is doing different things based on what other things in the process have done prior to it. So what I'm going to do is I'll walk you through a Monte Carlo simulation that I myself have actually built for a call center operation. But it's very important to start with what the call center operation is or what the process is to begin with. So what I'll show you here is the process flow and some of the logic and the statistical distributions that we used, and then I'll show you how I built the model. So our process flow is very straightforward for a call center operation. The customer calls in, they're prompted with a voicemail screening, right? And that's going to give them their options on how to proceed through the process. So you can press the billing, press 1 on your keypad and be directed to billing. Press 2 on the keypad and you'll be able to check your balance. This is a banking operation. Or maybe you want to talk to customer service, in which case you press 3, right? This is something that I think we've all probably done. So now that's the first thing, and that's going to progress us to the next step, which is our wait time. So our wait time is logically determined by what we pressed in the voicemail setting. And we see here the relative probabilities. So for billing, 15% of the people calling in are going to billing, 5% are going to check their balance, and the remaining 80% are going to be trying to get to customer service. So what we see with our wait time is that it varies depending on what we've pressed in the previous step. If we select billing, we're going to have this gamma distribution with parameters alpha equals 3 and beta equals 2. I have a separate video that talks about gamma distributions and why they're very useful in service operations such as a call center. So if you want to understand why we're using the gamma, you'll click on that video as well. I'll put it in the notes here. If we're just checking our balance, this is more of a deterministic process where I'm just redirecting the electrons in the phone to go and give you your balance. So we've got a very deterministic wait time of just a quarter of a minute. And then if we're trying to get call center customer service, we've got a gamma distribution of 10 and alpha 10 and beta 2. So what that looks like is a very long rate tail where we have different amounts of wait times associated with that. So what we also have from our wait times is a behavior of the person calling in. As you've probably done in the past, if you're waiting for too long, you're going to get discouraged, right? So what we're seeing here, and by discouraged, I mean you're going to hang up the phone and try to call back again later because you just don't know how much longer it's going to take. So in this case, what we have is that if you're going to wait longer than 15 minutes, 1 out of every 4 people calling in are actually going to hang up the phone. And then likewise, if you're waiting for longer than longer than 25 minutes, the remaining 75% will hang up that phone as well. So you can see here that we're, capturing behaviors based on statistical distributions, based on voicemail selection in a previous process. It's getting pretty sophisticated pretty quickly, right? Now let's say you get through to your the thing that you want. If you're selecting the balance, again, you're just going to be told what your balance is, and it's a very deterministic process. If you're getting billing services, again, we've got a gamma distribution with alpha of 3 and beta of 2. And then if we're calling customer service, we've got a different processing time that again follows that that gamma distribution with kind of that long right tail. And then after this, what we see is different success rates. So what we're reflecting here is, billing, 90% of the people are going to be satisfied with that interaction that they've had. The balance, 99%, because it's so automated and deterministic, we don't have a lot of unsuccessful processes of that. So almost 5% of our operation will always be successful. Then with customer service, what we see is that it's really dependent on the processing time, right? So if I call customer service and they can solve my problem within 10 minutes, they probably were able to solve my problem. But if they were able to solve my problem in 20 minutes, that probability goes down. Maybe I hung up the phone and I was dissatisfied. Whatever that is, whatever that processing time is, it's going to reflect that we're losing our ability, we're losing the success that the customer service representative is bringing to the process. And then if our process takes longer than 20 minutes, the customer service representative doesn't have a handle on the situation and therefore probably can't have a successful resolution of the problem, which means that this really goes down to 10%. And again, this is based off of the processing time in the previous step. And then we see the call is terminated. So that is our process. We can model this out and then we can start looking at key performance indicators, the time through system, the number of successful resolutions, the number of people are discouraged. And then by understanding our process, understanding the model that we've built, we can take actions to improve the current state and improve performance of our operation. So let's go over through the model. What I have here is a number of different columns. Looks like I have 9 columns. The first one is just a random number equals rand, and Excel creates a random number. And then every time the page is updated, this will generate a new number between 0 and 1. We'll use that for kind of the different logic that's built into this model. We have an index number, which is just there to kind of, for reference, we don't really use that number. And then we have the voicemail option. So in order to have these like probabilities built in here, filling 15%, check 5%, et cetera, we have to use something like this random number to randomly select the probabilities. So what I have here is, look, if this is less than 0.8, we're going to give a 3, which is 80% of our people going to customer service. So if this number is less than 0.8, and since the number is always between 0 and 1, 80% of those numbers are going to fall within that 3. Otherwise, if it's less than 0.95, which is that remaining 15%, it's going to be the option number 1. And then if it's neither of those, which means that number is between 0.95 and 1, we're going to get option number 2. So right there, we've got 2 nested ifs and 3 possibilities based off of a random number. That together simulates the random probabilities of people selecting either a billing process, a check balance process, or a customer service process. So now that's said and done. Process number 1 is out of the way. Now we can move to process number 2. Remember, process number 2 is logically based on what we select in column H for the voicemail option. So we'll say step number 1, step number 2, and you can see it updating each time the sheet updates. So now what we have here is if this voicemail is number 1, and it's not, but if it's number 1, we're going to follow that gamma distribution with alpha of 2 and beta, alpha of 3 and beta of 2. We use this cool function called gamma inverse, and we select a random variable equals rand, which is a random probability that follows a gamma distribution. And that's going to get us our wait time based on the option number 1. Now, if it's not that, if it's option number 3, we're going to also follow a gamma distribution using that same gamma inverse with a random variable for the probability. And then if it's neither of those, we're going to use that deterministic 0.25 minutes, which again corresponds with this wait time here. So if it's number 1, we follow that gamma distribution. If it's number 3, we follow this gamma distribution. And then if it's neither of those, we follow this. So again, 2 nested if statements, 3 possible options, but these if statements are based on the previous step. So that's process number 2 in our model is all set up, ready to go. Now what we want to do as well is capture, based on these wait times, whether or not somebody dropped out of the call. So this next column is a relatively simple if statement, and it's saying, look, if this is larger than 15% and a random variable is less than 25%, I want you to drop off. That give me a 1, which signifies that that what's going on is the person got discouraged. Or if this was larger than 25 minutes and the random variable was less than 75, that signals that second option of they can either be discouraged, 25% of those people will be discouraged if it's longer than 15, and the remaining will be discouraged if it's less than 70, if it's 25. So what we have there with the discouragement is based off of the wait times that we've calculated for step number 2. So we'll call it step 2 output, I guess. That's one of the outputs there. Now the processing time we can calculate again using the option that we had in step number 1 for our voicemails. So if we selected the voicemail option number 1, we know that that follows a gamma distribution of alpha 3, beta 2. And if it's number 3, what we see is that it follows a distribution of alpha 5 and beta 2.5. So that is our processing time. There's nothing to that. That's pretty much the same as the wait time. We're actually modeling it using the same statistical distribution. Next, what we want to do is figure out if it's a successful resolution. Now, I'm not going to get into all the logic. You can see in this formula bar that it's quite substantial, but we're looking at a number of things for successful resolution. We're first looking to see if they dropped off the call. If they dropped off the call, even though we calculated the wait time, our process output is unsuccessful, right? Because they weren't on the call. But now what we want to do is get into the resolution threshold, right? So based on what they selected for their voicemail option, we have different levels of success. If it's billing, they're successful 90% of the time. If it's checking the balance, they're successful 99% of the time. But if they selected option number 3, which is customer service, we have to then look at the processing time and have a different random variable for each processing time. So if the processing time, again, was less than 10 minutes, we check to see the threshold is 80%. If the processing time was less than 20 minutes, the threshold is 50%, and so on and so forth, based on our logic here. So again, lots of nested if statements. We're looking for maxes, we're looking for mins, and then what we're really doing for our successful resolution is checking whether or not, like I said, either if they're discouraged, it was not successful, they hung up the phone. Otherwise, we're checking against a random variable that says, okay, our threshold's 80%, which means if this random variable is less than 80%, which will happen 80% of the time, right? Then we'll be successful, otherwise we'll be 0. So these two actually kind of work together. One is setting that threshold based off of the logic. You know, I might call this step 4 or logic, that this is step 4 output. Okay. And then this is ultimately step number 4, processing time, the processing procedure. So again, I'm using the logic to figure out, based on all of the other options in subsequent steps, as well as some statistics that we've thrown in there to model the process, what the chances are that I'll be successful. And then I'm essentially flipping that coin in column M here, the successful resolution. I figured out my chances. It's not a fair coin. It's going to be heads 80% of the time. And then if it turns up heads, then I'm successful. And if it turns up tails, then I'm not successful. So these three are all taken together. And then what I can finally do is I can also model the time through the system, which is the wait time plus the processing time. But in the event that they were discouraged and they hung up after a certain amount of time, then I am only capturing the wait time. So you can see here a very sophisticated model. I mean, it's still crude. We could definitely nitpick different things that we've done on this, but you can see already that in just one line, we've really modeled an instance of somebody calling into a call center environment and understanding the journey that they took and how different possibilities have presented themselves. And now the best and most powerful thing about doing a Monte Carlo within Excel is that we can do this several thousand times. If I drop down all the way to the bottom, I'm at row 10,033. I've done this thing 10,000 different times, each with a different result, each with a different process or a different journey through the process. And now what I can do is I can capture and summarize those different experiences, which I've actually done over here. So by using just simple Excel formulas, what's the likelihood a customer calling in is happy with the service? Well, that's the average of that success in column M, right? I'll zoom out just a little bit so we can see how they're related. Look, I'm taking the average of a successful resolution. They're happy only if it was a successful resolution, and only 62% of the time did we actually get a successful resolution. Now, what percentage of the callers were discouraged, which means we're looking at this column J, and we found that 25% of them were discouraged, which is not great metric, right? 1 out of every 4 people is not even getting to talk to somebody because they're just hanging up the phone. They're waiting too long. Those wait times are far too high. That might trigger us to improve the wait times, which will ultimately improve our successful resolution. You know, if you're familiar with any kind of 5 why analysis, root cause analysis, if you started with like improving successful resolution, you might eventually get to wait times, and then you could figure out what's causing these high wait times. And solving that problem will ultimately have a higher leverage solution for the successful resolution. What percentage of the callers stayed on the phone for greater than 60 minutes? It was a very small percentage, 0.08%, which is like 8 people out of the 10,000. So very few. That's because most of them are hanging up. That's what's going on there. And then what's the average time through the system? I don't like that formatting, bear with me. What's the average time through the system? All we're doing there is just averaging out column M, which is our time through the system. And we see that it's about 24 minutes, 25 minutes. But again, as people are getting discouraged, they're actually hanging up the phone, and that's actually decreasing the time through the system. So this might actually be higher if less people were discouraged. So this might be a bit of a red herring, but it's definitely something to consider. So this in a nutshell, in a lengthy nutshell, is how we would go about doing a Monte Carlo simulation to show the different dynamics and a different level of sophistication for some of our operational processes. It's definitely helpful to understand your risks of the business from an operational perspective. You can really use these to improve decision making when it comes to larger decisions, such as adding headcount, adding different machinery and capital to our process. So all this to say, the Monte Carlo simulation doesn't take a lot. You have to know what you're doing. You have to know some statistics. But other than that, it's a really approachable solution to understanding the dynamics of an operation. In a subsequent video, what I will do is I will show you how we can actually look at diagnostics of a Monte Carlo simulation and say, what if I changed this variable a little bit? What if I changed this? What impact would that have on my business, on my operation, on my process? So I really hope you enjoyed this tutorial on using Monte Carlo simulations in Excel. If you have any questions, please reach out to me.